Our keywords here were, we were on quantitative and qualitative. Who can describe what it means to be qualitative data?
It's not like any exact measurements. It's kind of like biased, like colors, stuff.
And what's quantitative data?
It's like measurable.
In what system? You can all say it together. Good morning. Oh wait, is that one's fifth hour, right?
Yeah.
Okay. Thank you. So, measured in the metric system, qualitative. Qualitative data describes the quality of something. So, fuzzy, green, pink, glittery, descriptors, right? And like we discussed yesterday, how we all perceive things, the number one piece of qualitative data students want to use when designing an experiment is color. They want to describe color. And for me, that's always the number one example of how we all perceive things very differently. What you might say is one color, I may say is another, and what I may say is that color, Mr. Zemba likely would have a very different opinion. We all perceive colors differently and make color distinctions differently. If I said that your polos are a blue-red, but the buoy chair is an orange-red, how many of you are like, yes, I would make that distinction? Like, that makes sense to me, this idea of blue, red, orange, red. And some of you are like, red? Red. You're the red? How many of you are like red people? And how many of you were blue, red, orange, red? We're always fewer. The people who make like distinctions based on tone are always, it's another thing my husband does not get, distinction based on tone. He's not allowed to pick out paint colors in the house because he can't distinguish those undertones. The house would not match. It would be dreadful. So I did all of that. That's the other thing is my fine redheads in the back. Never understood why we called you redheads. Right? That. I don't see red. Do you see red when you see your hair? Right? Like, truthfully, it's not even orange. I see copper. Like a penny, right? So, qualitative data is one of those things where we can spend forever quibbling about it. We can make all kinds of distinctions. There is another piece of qualitative data that people think is quantitative because it involves numbers. You think quantitative, quantities. Oh yeah, I gave you that little piece of paper yesterday. This is a piece of qualitative data people think are quantitative because you hear quantitative and you hear quantity and then you think numbers and then you see numbers and you think quantitative. But don't be bamboozled. On a scale of 1 to 10, this is a 7. This is a 5. We call, anytime you put something on a scale of 0 to 5 or 1 to 5 or 1 to 10, it's called a Likert scale. So it's called the Likert. And it involves numbers, right? You're like, yeah, 1 to 10, those are clearly numbers. But this is my favorite one of all. And this is one that I've seen a lot lately. So this whole process involves a great deal of pain. And when you go to the doctor, every time they go to the doctor, they're like, so what's your pain on the scale of like 1 to 10? I'm like, I don't know. What is a 5? Like, what if I've never experienced 10 as pain before? Like, to me, 10 is like passing out. I'm in so much pain. So every time I go in, I'm like, 2, 3, I don't know. And she's like, well, have you ever experienced more pain? And I'm like, lady, I run marathons. Like, yeah. But yeah, if I came and kicked you in the shin, don't worry, I'm not going to. That wouldn't be very nice of me. If I came and kicked you in the shin and I was like, okay, put that on the pain scale, 1 to 10. Where would you put it?
7.
It depends what shoes I'm wearing, right? I've got some pretty viciously pointy high heels. Yeah, see? So, our perceptions of pain are likely very different. Truth be told, another throw my husband under the bus. If he had to put my pain on a pain scale for him, good grief, he'd be like, an 8? He doesn't handle pain well. He doesn't, never has, never will. Whew. So, that's not numerical data. It appears to be numerical data, but don't be confused. Likert data is dreadful data. None of you are ever going to give me a scale of 1 to 10 as data collection for experimental design, are you? Okay, good. That's good, because every unit will be designing an experiment, and I really don't want to have to ever see a Likert scale. That'll stress me out a little bit. I'll be like, we had this talk. Why is numerical data so important? Right, we like it because it's specific. Quantitative data. Take till the clock says 8 and discuss with your partner. Come up with the top 3 reasons we like quantitative data. Top 3 reasons we like quantitative data. Who thinks they have number 1?
It can only be perceived one way, unlike qualitative data where people could think about one way.
If you are reading a digital scale, there's only one way to read it, right? There is an absolute correct answer when you read it. Now when we use a ruler, there's always our doubtful digit. How many of you know about the doubtful digit? Yeah, we'll practice measuring things before you actually do a lab then. No doubtful digit? The estimated digit? How many of you, when you read a ruler, just read the line that's on there? You're like, oh, 1/2 centimeter.
At first.
Well, we'll teach you how to read a measuring device then. Maybe that we'll take a slight detour next chapter. So it's objective. Reason number 2. Who thinks they have a second reason?
It can't be disputed.
Can't be disputed? If you use a thermometer and I use a thermometer, we're both likely going to come up with a very similar, very close temperature. Robbie? So it's going to be more accurate.
I think it just, people like the sight of numbers more. I think it makes it feel more like distinct and accurate, like Ronnie said.
So we see numbers and we automatically associate them with math. And when we see math, we clearly think like, oh, well, they must be smart, right? It must be correct. There's math involved. How many of you are like, yes, math lends some credibility. Quantitative data does, in fact, lend some credibility. That is entirely true. It's about that whole objective, accurate, not disputing things thing. What can I do with numbers that I can't do with words?
They can be changed,
Changed how?
like you can add to it, they can't like add quantity.
So I can add, what else can I do other than add numbers?
You can't like make numbers like sometimes word order, the way someone says something could be confusing.
Okay, so there's clarity in a number. Like 1 centimeter is 1 centimeter is 1 centimeter.
It's easy to compare to the numbers.
Comparisons, how about, is a comparison a particular kind of analysis? Right? I can do mean, median, mode, those things. I can do that with numbers. Can you do that with words? Can you make a graph with words? Well, there's one particular, well, 2 stinky kinds of graphs that can sometimes be made with words. Kinds of stinky graphs could be made with words.
Venn diagram.
Venn diagrams. There's another one that's like a circle.
Pie chart.
Pie charts, right? You guys are like, oh, but a pie chart's a graph. Do you know how much scientists loathe pie charts? I could make a pie chart of anything. I could pie chart the percentage of pies in this building. That's ridiculous. Scientists don't like those. So numbers lend themselves to a particular kind of analysis. So we collect our data so we can analyze data. Data analysis involves math. There are many times throughout the year that students are like, I don't understand why to get into honors science, how I am at math mattered. Why do you care how I am at math? Well, I require you to do a certain amount of data analysis. And if you come in here day 1 and I say mean, median, and mode, and you're like, I think I can do mean, median, and mode? Maybe. Those are the most basic of all analysis that we'll do in here. So this is the moment for some of you who are currently panicking. You're like, I know the words, but I don't remember what they mean. Mean is average. Median is? And mode occurs? Excellent. So it does require, data analysis requires some math. The very, very simplest of all data analysis is going to be mean, median, and mode. Then we graph things. Our favorite graphs are line graphs and XY scatter plots. We are not big fans of bar graphs. We don't particularly care for pie charts. And as we graph things, I want you to remember as we graph them, we mix them dry. We put the manipulated or the independent variable on the x-axis and the dependent or responding variable on the y-axis, and that's going to show us a relationship. What our line or our xy scatter plot does there, the slope of that line, that whole y equals mx plus b thing, rise over run, that's going to tell us about rate of change in science, and we care an awful lot about that when we do data analysis. So if you didn't come to me with that particular skill set, this particular chapter would be especially confusing in this section because every single good experimental design is going to involve some statistical analysis, numbers, data, math. You guys math people? Oh, that's good. I'm about to make this way harder. After you analyze, what should you do?
You should tell it to people.
Before you can tell it to people, what do I do?
Find out if someone else did the same study.
Could do that.
Publish it.
How many of you are like, got to draw a conclusion? I make the graph, then your conclusion interpret the graph. Tell people what your graph means. Did it support your hypothesis? Did it not support your hypothesis? Then, if you are a scientist who gets paid to be a scientist for a living, Then, my friends, you get to share your data, publish your data, right? I do believe, if I am correct, that takes us through the end of our outline. Analysis, conclusion, theory versus law. Yeah, we'll do that later. I would rather see you do something else. So I asked you while I was on retreat and while you were here to write an experimental design, right? And I am just going to guess that it was difficult. Accurate? Yeah?
I think the most difficult part was not being able to like have it and do the experiment ourselves. We had to guess what we were doing, and we had to like search it and look up and make sure we had the right ideas.
So here's why I love that. This is what I love about it. Science so far in your laboratory experience has been being given a set of instructions and you following them, right? That is not an experiment, no matter what someone told you in your past. If you walked into your middle school classroom and your teacher was like, you're going to do an experiment today, and they handed you a series of instructions, it's not an experiment. You know how I know it's not an experiment? Your teacher knew exactly what was going to happen. Your teacher knew the outcome. Somebody else knows the outcome, that's not an experiment. That's a lab. It is a laboratory experience, it's a demonstration, and it has value. I'm not saying it doesn't have value. It has a place, but it's not an experiment. What's hard for you guys is I'm not sure all of you have been expected to do experiments before. You do them naturally in the world. If you say, I wonder what would happen if, and then you follow that impulse, I wonder what would happen if I kicked Aaron in the shin. You don't look nervous.
Not really.
Am I not frightening?
Pretty confident that you won't kick me.
How many of you are confident I won't kick him?
Appreciate the support, guys.
Those of you who didn't raise your hand, is that a testament to my character? You're like, yes, she clearly kicks students, puppies, and small babies. Not large babies, though.
Just small.
Just small ones. Get more distance on the smaller ones. So, if you've ever followed that impulse not to kick children, you shouldn't do that, just, to be clear. If you've ever followed that impulse, you've done an experiment, but it was hard because I asked you to write an experiment. And that meant starting from zero. And in education, we call that synthesis. I've given you information, and I expect you to create something brand new. And that's scary, and that's hard. So what I'm going to have you guys do is a little bit of peer review without publication. You are going to find your partner. When I say break, you're going to find your partner that you worked with on your experimental design. And you are going to find another group, and you guys are going to swap experimental designs. You're going to determine how well the other group was able to follow the scientific method. Hint, there's a rubric for this that exists somewhere. You could probably open the rubric and just fill it out as a PDF, like download a copy, write their names at the top and fill it out, circle and write comments. Here's what I want you to think about. For some of you who are like, but it was hard. I know. I'm okay with that. You're like, but I was confused. I know, I'm okay with that too. It's okay, not asking for perfection yet. First time through something, are you ever great at it? You like all like child prodigies of experimental design? Lucas, why did you laugh? What are you a child prodigy at? So what I'm going to ask you to do is think about it this way. I've given you how many characteristics of life?
7.
There are like 6 of them, right? Homeostasis, metabolism, respiration, yada yada, blah, blah, blah. You remember those?
Yeah.
When you check to see if something is alive, you should be looking for one of them at the minimum, right? So your experiment should have explored whether or not your sample would have done one of those 6 things. I personally would have chosen the one that's easiest to measure. I like respiration myself. I would have attempted to feed those items and then determined if they excreted carbon dioxide gas. That's what I would have done. How many of you are like, yeah, that's what I did? How many of you are like, I said observe it and see if it grows? How many of you added some resources first? You're like, well, it's not going to grow in the Petri dish. It hasn't outgrown the Petri dish yet. Okay. So you're going to swap these with people and see how well you manage to take those 6 things that you know to be true because of some research and prior knowledge and determine if those things are alive. Fill out a PDF. You only need to fill out 1 rubric for the experimental design that you're evaluating, 1 rubric for the pair of you, but you're going to discuss what they did well and discuss what you think they didn't necessarily do all that great. But since you guys have PDFs of these things, they should be super simple to share with each other, right? Brilliant. So that's what I want you to do. Go ahead and break.
Not